Imagine you're telling an AI that you're building a startup. The AI responds helpfully, asking about your business model and challenges. But then you ask a follow-up question, and suddenly the AI has no idea what you're talking about. It's frustrating, isn't it? This brings us to two key concepts we'll explore today: context memory and RAG. Context memory is what stores your conversation history, while RAG, which stands for Retrieval Augmented Generation, is a technique that helps AI access external knowledge. These are the building blocks we'll use to solve the memory problem. Over the next few minutes, we'll dive deeper into how context windows work, why bigger memory isn't always the solution, and how modern AI systems are tackling these challenges. Now let's dive deeper into how AI actually handles information. We're going to explore the concept of context windows, which is fundamental to understanding AI memory limitations. Here's the key point: AI only sees information that's currently inside the context window. Nothing outside of it is accessible. Think of it like a temporary whiteboard in a classroom. This illustration shows exactly what I mean. The context window is like a whiteboard with limited space. As we write new messages, they fill up this window. When the space runs out, older information gets erased to make room for new messages. This is why AI appears to forget earlier parts of a conversation. So the context window isn't permanent memory, it's temporary working space. Once something falls out of the window, the AI literally cannot see it anymore. This is the core limitation we need to understand before we explore solutions. Let's dive into why simply making the context window bigger isn't actually the solution to our memory problem. As we just covered, context windows have important constraints. Imagine if you had to read 10,000 pages of information just to answer a single question. That's what happens when we try to solve memory problems by just expanding the context window. It's incredibly inefficient. This inefficiency comes with real costs: more processing power, higher expenses, and slower response times. Sometimes, paradoxically, it even leads to worse accuracy because the model gets overwhelmed with too much irrelevant information. Here's the key insight: the problem isn't about memory size at all. The real issue is how we organize and retrieve information. We need a smarter approach, not just a bigger one. Think of it like a library. Having more books doesn't help if you can't find the right one quickly. We need a better cataloging system. And that's exactly what we'll explore next with RAG. So, RAG stands for Retrieval Augmented Generation, which is our solution to the cataloging problem we just discussed. Let's break down what this means. Retrieval Augmented Generation combines two key processes: retrieving relevant data from external sources and generating responses using that information. This diagram shows how RAG works. When a question is asked, the system searches databases for relevant information before generating an answer. First, RAG stores information externally in databases rather than relying on the AI's internal memory. This solves the problem of limited context windows we explored earlier. Second, when needed, the system actively searches for relevant information instead of expecting the AI to remember everything. Third, this retrieval process ensures answers are based on up-to-date verified data. Finally, it allows AI to handle complex queries without memorizing entire knowledge bases. Now let's look at real-world examples to clarify the difference between context memory and RAG. First, consider context memory. Imagine a customer support AI that temporarily remembers your order number during a chat. This is like short-term memory. It holds information only for the current conversation. On the other hand, RAG is like a chatbot that searches a company's documents for refund policies. Instead of memorizing everything, it retrieves relevant info when needed, similar to opening your notes or searching Google. This visual comparison shows how context memory handles immediate interactions, while RAG accesses external knowledge. Both are essential for different AI applications. Let's move on to how modern AI systems actually work in practice. After our learning context memory versus RAG, you might be wondering, which one do real systems use? The answer is both. Modern AI systems combine context memory and RAG together in what we call a dual approach. This gives us the best of both worlds. These systems store conversation summaries and user preferences so they can maintain context across sessions without needing infinite memory. Think of it like human memory. We don't remember every single detail of every conversation we've ever had. Instead, we remember the important summaries and key points. This is smart design. Rather than building systems with infinite memory, we build smarter systems that know what to keep and what to summarize. So the key takeaway here is modern AI doesn't choose between context memory and RAG. It uses both strategically to create efficient, intelligent memory systems that work the way human memory does. Let's summarize the key takeaways from our session today. Understanding how AI manages memory is crucial for building effective systems. First, context memory is temporary and fast, operating within the current conversation session. It's like your short-term recall during a discussion. Next, RAG enables external knowledge retrieval from documents and databases. This allows AI to access vast information beyond its initial training. Real AI systems combine both approaches strategically. This integration ensures optimal performance by leveraging the strengths of each method. By merging context memory and RAG, advanced AI simulates long-term memory. This is how modern assistants maintain continuity and depth over time. As we conclude, remember that effective AI memory isn't about size, it's about smart architecture. Great work, everyone, and keep exploring these. In the next video, I'll go even deeper into RAG architecture, ingester, and retrieval pipeline. So if you want to truly understand how modern AI works behind the scenes, make sure to subscribe to the channel because we're breaking down complex AI concepts in the simplest way possible.